Thank you very much for coming.
Congrats, guys, for making it until now. I know it's been a long day, and we're actually so happy to see so many of you. We were a bit worried that everyone would be back to their hotel or catching up a train, so we were glad to see the queue out there. And just before we start, I'd like to clarify that this session is not on visualizing dense data. If you've heard of it through word of mouth, I know many of my French colleagues thought I was going to talk about ballet and dense. I am not. We're going to talk about dense, D-E-N-S-E data. So a quick introduction. I'm Jade, and this is my colleague Florian. We are both on the Tableau public team, which means that we work with newspapers, public organizations, and also private organizations to help them publish their data onto the web. So we help them create nice visualizations, and we have some examples here on the slide. Some newsrooms worked with Tableau Public, like Le Figaro or L'Equipe in France, CNBC in the US, or Florian helped the UNICEF create this wonderful viz over there. So that's what we do, and in our job we get to see a lot of data on a broad diversity of topics. So this is why we thought that dense data is something that people don't necessarily know how to deal with, and this is why we created this session for you. This quote by Edward Tufte summarizes the challenges of dense data quite well. So the problem that you face as business analysts most likely is that of presenting large amounts of information in a way that is compact, accurate, adequate for the purpose, and easy to understand. Your stakeholders, your managers, they need to see some data that you have simplified for them, you make it understandable for them. And so that's basically what we're going to help you do today with some simple techniques that you can then apply on your day-to-day job. An image being worth more than 1,000 words. Here is an example of dense data, and this is actually, I'm not too proud of it anymore, but this is my first visualization I've ever published on Tableau Public. And this is the visualization that got me into Tableau back in the days. I would clearly do things differently if I had to redo it today, but I will tell it what it is nevertheless. So it's about open data on French sports infrastructure. And you can see very clearly on the bar chart what's happening. So green color is for outdoors sports equipment like football, like soccer, and rugby fields. Red is for tennis, and basically it's following the order of the icons at the top. And so it's clear on the bar chart that in France we have a lot of outdoors fields for mostly boys. Then tennis courts, which was quite surprising for me, and then horse riding facilities, which is even more surprising. But what's interesting here in terms of dense data is that the map has a lot of points, and basically you cannot see anything because we have a blatant case of overplotting here. So this is the kind of challenges that we're going to teach you how to solve, trying to avoid having marks on top of each other and not letting people see what's the insight in there. And before we dig into the topic, I will just let Florian introduce himself quickly.
Yeah, thank you. Just on that point, I mean, it's true that this map is confusing. There's a lot going on here. But at the same time, we all love maps, and we all want to click on individual sports fields and be able to see what's there. So that's really the challenge there, that dilemma that we face. Now, when Jade asked me to do this session with her, I also didn't know what dense data was. I did not think about dancing necessarily, but I didn't know what it was. But after looking into it and seeing examples like this, I realized this is actually a topic I'm a bit familiar with. And in fact, it's a topic that got me interested in data visualization in the first place. So a couple of years ago, I was working as a researcher at a business school, and I had a problem with my data, and I was running these regressions, and I wasn't getting the results that I was hoping for. So I went to the statistics department, and the people over there, they said, well, you economists, why do you always try to fit linear models to everything? And then they recommended me to actually look at my data first and see what is the pattern in the data, what is the shape of the data, and then choose an appropriate model afterwards. And so that really introduced me to that whole world of looking at data and visualizing it, while at the same time maybe summarizing it, such as in a bar chart, or using a regression or some other summary statistics. So I can see the benefits of both, and I want to introduce some of those techniques that I learned back then today as well. And one book in particular that I recommended back then was a book by William Cleveland, or actually two books, a famous statistician who has a whole catalog of techniques that one can use to visualize data and make sense of data. And we'll look at some of those techniques today. It is an advanced session, but we are going to start gently, so there should be a little bit for everybody here. We will not go into all the details of all the formulas. It's the last session today, so we just want to talk about the logic today, but you'll be able to get all the resources on Monday. You'll get a link to the slides and the workbook, so you can look at the formulas in detail. And also, another thing to keep in mind, obviously not every technique works for every use case, but we hope there is something for everybody, and maybe that's the homework on the flight tonight or on the train tonight. Think about what is the use cases that you might find useful for your challenges that you face on Monday when you look at your data set. Just to go back to that slide one more time, we do have this conceptual framework where we try to group these techniques. We want to spread marks out first and see whether that helps us. When that reaches its limits, we're going to do the opposite and bin marks and try to gain more information that way. And then taking it to the extreme, we'll be looking at summary statistics in addition to seeing everything underneath those summary statistics. So trying to combine the best of both worlds, seeing individual marks, but also getting more information from summary statistics. So that's the kind of techniques we want to look at, and we've got a nice data set prepared for that, don't we?
All right, yes, we do. So I'm going to open this in Tableau. From now on, we will move from the PowerPoint to dig into the data. Our data set today is about the London Marathon. So we've got 40,000 finishers of this marathon. And it was always in my mind when I was preparing for submitting this session that this should be running data, because it's clearly when you see the images from above, people crossing the finish line, you've got a massive amount of people finishing at the same time. And so I thought this would be perfect to visualize dense data. So if we look at this data set, we can check the finish time, the average finish time of our runners. And I'll just make a quick average so that we see. It is 4 hours 84 minutes, 4 hours 0.8, which is 4 hours 50 minutes. But this doesn't really give us a clear idea of what's the actual range of the data. And if we look at all the individual finishers, which is what I have plotted here on this dot plot, we see that the fastest guy finished in 2 hours 19 minutes. And the slowest person finished in 9 hours, 33 minutes. So it's a very, very broad range, and this summary statistic, which is the average, is not really helping here to understand what's in my data. So when I'm facing this massive data eclipse, the first thing I will try to do is obviously filtering. So I could just focus on what's of interest in my data, and let's say I'm interested in seeing just the best runners, then I would simply bring a filter. So here I have my filter for anyone that run in 3 hours or less. I would bring it here, and then I get a subset of my data which may solve the eclipse problem or may not. Here, still not very clear what's happening. I just see that the fastest guys are really fast and no one can catch up. But as soon as I'm over the 2 hours 45 minutes mark, it's very dense. So that was the first technique, very easy. We are trying to warm you up slowly. We will have more complex formulas later. The next option would be to change the marks type. So in this case, I could just try to put something more transparent or see-through mark. So if I go to shapes and change it to, for instance, these hollow circles, I kind of see a bit better what's happening. Of course, my data is very dense, so it's not solving completely the issue, but in some cases it might. And then the last easy trick is, of course, to play with the transparency of your data, and you see that it's, again, the same. We see that not so many people are running really fast below 2 hours 30 minutes, but after that it's kind of a blur and we cannot really make any conclusion. So I'm bringing in the first more helpful technique here, and it's still quite easy. It's the jitter solution. So who has heard of jittering before? Okay, that's like not half of the room, so some people will learn something. Jittering is basically offsetting the marks on a vertical axis based on a random number. So here, my jitter formula, if I open it for you, is just generating this random number that I then put on the vertical axis so that it will spread my marks and I won't have this massive data eclipse anymore.
And this random number is by default between 0 and 1.
Yes.
So if you need a higher number, you have to multiply it, but this formula will give you a number between 0 and 1.
Indeed. So I hide the axis because it doesn't mean anything, right? The random number is not something that I want people to think about, but it just allows me more clearly to see how many marks exactly there are in my data set. And now we get a clearer idea that at the very beginning we have those very happy few that run really fast, and then it's really dense at the end, and in the middle it's getting denser.
And it's also easier to click on the marks and find
yeah, if you want to find individual people or whatever you're looking at, then you can. And I'll show you how easy it is to do it. So I'll just create my formula here in the rows section. And it's a simple random parenthesis, and that's it, you get your jitter.
This is for the whole data set now. Just now we looked at the 3 hours and less.
As you can see, I still have my person who ran in 9 hours, 33 minutes, and I still have my best guy. And in the middle, I can see that it's, like we said, the average is around 4 hours, 50 minutes. So we see that indeed there are lots of people finishing in that time, and it's like a normal distribution. Florian will show you a bit more about the statistics because that's his specialty, but you can already start to get a feeling about what's the distribution of our data here. So Florian, why don't you show us the more like statistician way of doing it?
So we want to look at the distributions, but I also want to dig in a bit more and see, okay, so we've got a few people on the left, very fast, and then a lot of people in the middle, and then this very long tail of kind of very slow people. So I really want to dig in and who are those slow people, who are the fast people, who are the ones in the middle. And the nice thing, of course, in Tableau is you can break up the data with your different dimensions. And we've got 2 dimensions here. We've got gender and we've got age groups. So I thought the next step after seeing this, we both thought it'd be nice to kind of explore how these factor in here. So one thing you can do is, this is the same plot really, just different size of marks. Size obviously also matters, right? The bigger the marks, the more overlap and the more overplotting you have. So one thing we can do is we bring gender in here. And so you might want to bring it on color. And what you can see now is the very fastest people are obviously men. Well, for athletes, I mean, we know it's, athletes tend to be the very fastest, tend to be men. But then towards the right, we can't really see very well what's going on. Also, there's a second problem here. Tableau plotted the female dots on top of the male dots. So it actually looks like there are a lot more women taking part. Which is actually not true. I know for a fact there are more men taking part in the marathon than women. So one thing we can do here is we can shift the gender variable here. We can shift that down one spot and ask Tableau to use a runner number to sort the dots. And that happens to be randomly, according to the runner number, and that's happens to be randomly assigned. If not, if that was also based by gender, so first the men and then the women or the other way around, you could randomly sort it again with a random formula, so another use case if you want to sort your marks. So now we get a bit better representation for where the men are, where the women are, and we can see there are actually more men in this data set than women. Still, we can't really see what's going on the right-hand side. Are women more among the slower ones or more men amongst the slower ones? So now we have to really separate the marks out better. Right? What you can do, of course, is put it on the rows, and we get a bit of a better idea now. but it's still, there's a lot of stuff going on. So we need to start using some of our summary statistics. So we might want to bring in a box plot, for example. And we can see now the distribution is quite similar. So the box is similarly shaped. The extent of the whiskers is similar, only that it's all shifted down by a little bit. So the median for men is around 4 hours 30, and for women it's a little over 5 hours, so a little more than half an hour slower for the median runner. So that's one way where the box plot helps us see the distribution and compare the two distributions. At the same time, we still have the individual marks, so we can click on those outliers and can see who they are. And that's a really popular combination, the dot plot with the jitter and the box plot on top. You might want to look at the box plot and the distribution in more detail, and of course one popular technique for that is the histogram. We lose the individual marks, we're binning marks into groups, but we get a very clear idea of what the distribution looks like. There is a show me this type for that, but since this is an advanced lesson, we can quickly build our histogram. So all we need is, we need our finish time, and we say create bins, and I'm going to say 1,800 seconds, which is half an hour, so I get bins of half an hour, and I'm going to use that on the horizontal axis, and I'm going to use the number of records on the vertical axis, and I already have my distribution for the whole data set, and I'm going to break that down by gender. And we've got a couple of nodes that I'm going to exclude here for now. And we see the same thing that we mentioned just now, that the distribution looks similar. It's shifted a little bit. Another interesting thing though here is, because we have got more males, it all looks taller, so it's actually difficult to compare. So one way to kind of compare just the distribution, the shape of the distribution, would be to use relative values, so percent of total. And you want to make sure that you're using the bins there in your table calculation. So now we've got just the shape, and I'm not going to do the calculation now, but another thing you could do would be to demean it, meaning you subtract the sample mean from each individual bin or each individual item, and then you bin it, and then you get the center, the peak of the distribution at the same, so you shift the two on top of each other, and what you get in the end is they're actually pretty much the same. So the men and the women, the distribution of the shape of them is really the same, they just shifted again by that half an hour. The reason I mentioned that is it's because it's different for the gender, for the age groups, and that's the other thing I mentioned. We wanted to look at the age groups, and with the age groups it's a little bit different. So if you bring age groups here, we'll notice a couple of things. So on top we've got the youngest runners, 18 to 39, still among the youngest here. And then we've got 40 to 44, 45 to 49, and so on, until 70 and plus. One of the things we see, of course, is fewer runners in the older age groups, no surprise there. The other thing we see is, when you look at the left side of that, visually, there's that diagonal, right? The top runners tend to be in the younger age groups, also no surprise. But then what's interesting is we've got this other diagonal here, visually at least, that's our first impression, right? So the crazy long times of 9 hours, 18 minutes, that's also, predominantly in the young group. So that's really interesting. Some people really don't know what they got themselves into there, or really overestimated themselves. That's what it looks like, and we can confirm that if we bring a box plot here. we can actually see those outliers here. They actually bring the whole distribution all the way up here. Then we've got these crazy outliers beyond the viscous. The median value and also the mean, I've checked it, they're actually lower for the youngest age groups than for the next age group. Only then, after that, does the mean and the median start to kind of drop a little bit. But also for the older groups, the distribution shrinks a little bit. It becomes a little bit more compact. And we can see that again when we do these relative box plots where we normalize everything. It kind of shrinks a little bit, not too much, but a little bit. So it seems like all people are slower, but not crazy slow. So they know what they get themselves into when they take part in a marathon. And that makes sense, right? You probably have run a few marathons when you're 70 plus and you enter a marathon. I don't know, maybe. But that's something we can check a little bit more, that theory. We've got another interesting variable in here. We've got split times in here. So what we want to do next is we want to look at two different variables together. So moving away from a one-dimensional world to a two-dimensional world. But before that, let's do a quick stock taking, what we've covered so far.
Yes. So before we move on to dig deeper into this hypothesis that the older runners are more experienced and might have a better alignment between split time and finish time, I'm just going to recap what we've seen so far. So we've started really easy with the techniques of differentiating and spreading your marks. So we saw that you could change the transparency, use hollow marks type, and then use the jitter with a simple random formula. What we saw as well were the box plots. So on a dot plot, you can use the box and whisker to see what is the distribution, where is the mean, and where are the outliers. And the histograms are also a good technique to see the distribution. And now we're going to start looking at more complex forms of visualizations. Shall I? Yeah, we'll look at small multiples, heat maps, and hex bin polygons. So this is quite exciting. Stay tuned.
Yeah. Thank you, Jade. So we are going to the two-dimensional world now. We are going to look at the half time, so the time at the half point mark, the split time there, which is on the horizontal axis. And then on the vertical axis, we have the finish time. We also added 2 times the half time on a dual axis plot, and we show that as a line. So this is the theoretical line that you would be on if your finish time is exactly twice your half time.
That's the perfect line.
Yeah.
If you have the perfect pace and you're always running at like 10 or 12 kilometers per hour.
Is that what people aim for? So you've actually taken part in a marathon. I have never done anything even close.
I've seen some runners in the room nodding about some stuff. Yeah, the goal is to have a really regular pace, and that's the best way to finish in a good shape.
Yeah. But we do see, of course, most of the dots are above that line, so most people actually slow down in the second half of the race, which makes sense. I understand. The best people, the ones all the way down there in the bottom left-hand corner, they are quite close to that perfect line. So the professional athletes, they are really good at pacing themselves. But we do see those crazy outliers again, and now the question is, of course, are those the young people? Where are the old people? Are they really good at pacing themselves or not? So let's try to bring age onto the view. Let's add it to rows as before, and now we have a problem because we're breaking it up by rows, and our scatter plot is getting squashed, and it's really difficult to see what's going on here. You could, of course, stretch it out, but then you have to scroll up and down, and it's really difficult to compare. So I'd like to introduce you to an alternative view, which is a trellis chart or a small multiple chart, which basically gives us this nice grid layout here. And so now we can see each of the scatter plots as a square. We have each of the age groups there going from young to old. And we can answer our question now. We can see that the old people, they are, they're higher than above the perfect pace, but they are relatively close, whereas it is indeed the young people, some of them, not all of them, but some of them who are way above that 45-degree line there. So that answers our question. But of course, I want to talk a few minutes about how we did this. Now, this is not something you can do with 2 clicks, unfortunately, but it is not too difficult either. So there are a couple of table calculations in here. And once you've done it once, or once you've set it up once, you can use those for every workbook that you create. The way it works is, and this is quite neat actually, we have a parameter here, and this is just for this is just for showing off really, added effects. We can actually change the layout by clicking this parameter, and so we can choose how many columns do we want. Then we have 2 table calculations, one for the rows and one for the columns. And it basically, what it does is, we use the index function in there to assign each of the age group a number. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we divide that number by the number of columns that we want. And then we actually use the modulus, which is the remainder of that calculation. And what it does is it gives us this nice pattern. It's like 0, 1, 2, 0, 1, 2, 0, 1, 2. So we can assign every in this case, every third age group to the same column, and then every other third column to the second, every other third age group to the second column, and so on. The one, I won't open the formula because I'd rather you look at that on Monday morning, but what I will point out is when you go into the table calculation, you'll need to look at this here in detail. You need to be sure to include all of your dimensions because you want to count across all of the marks in your view. But because you want to assign numbers based on the age group, you need to say at the level of age group. So we're going 1, 1, 1, 1, 2, 2, 2, 2, and we're assigning the numbers of the age group to each individual mark, if that makes sense. That's the scatter plots. If that was too fast, either we can take a quick question now or we can look at it again later, or again, you'll get all the formulas and all the workbooks afterwards. And I'll switch screen.
Okay.
Yeah.
All right, so far we've been looking at all the marks except for the histograms we were binning, but here for the dual 2-dimension scatter plot, we were just keeping everything on. This makes it difficult to answer simple questions like which is the best time, like which is the time where we have most people finishing and doing, like which is the half mark and the finish time where we have most runners in. And so this is what we're going to see now together. We're going to bin our scatter plots in various ways so that we can see more clearly what's the distribution in there. I'll start with a heat map, and let me show you what it will be very soon in Tableau.
Yeah, I think you might have seen this yesterday when our devs on stage, when they introduced a new feature called density marks.
I'll show you how easy it will be, and then I will show you how not so easy it is so far, but not too difficult either. So in the future, you will just have a new marks type here. You see, we have currently the polygon is the last one in the list, and soon you'll have the density marks type. So it looks like this. Automatically, it creates this heat map. The default color palette is still this blue, ice blue diverging, but then if I use a temperature diverging, I get a nice heat map that I can just then adjust by playing with the intensity of it and the opacity. So this will become really simple. I see some people are happy about this upcoming feature. Now, if I go back to the normal current way of doing it, it will have to do with binning. And so what I will do is, Florian already created some bins automatically. I have created bins in the manual way, which means by a calculation, because the bins that Tableau creates, the bin data type, is not something you can use in calculations. While in the next techniques I want to show you, I will need to use those bins in calculations. So my bins, to show you what it looks like, are here in my bin calcs folder. By the way, I don't know if you use the folders, but that's a really good way when you have lots of formulas in your workbooks to keep everything in order. If you have questions about this, I can show it to you later. So how did I do bins manually? I just took the integer of my finish time here in seconds, and I divided by 60 because I want to round it as minutes. And then I multiply it by 60 again to put it back on the seconds axis. And once I do this, for both the finish time and the half time, I will have bins. So if we look again at the original one, we see that we have 40,000 marks, so we have all our finishes. And then if I bring in my bin finish time and bin half time, we see that we only have 7,900 marks. So we've grouped everything like we do in a histogram, but this time we've done it on the two axes. We've made small bins of people. And then easily with our bins we can play with the transparency and the color. So if I bring number of records on color, and then I choose again my fabulous temperature diverging color palette, then it will start to look a lot more like a heat map. And of course I can adjust the colors. So here I know that we're looking at bins of 1 minute breadth and height. So if we have 10 people finishing in exactly the same minute and exactly the half time and the finish time in exactly the same minute, that's already quite a lot of people. So I'll change the maximum of my color palette to 10. And here I have a heat map pretty similar to what we created there. So not just a one-click move, but still pretty easy to do. And this is nice, but it still doesn't allow me to answer the question. If I'm wondering what's the most common half time and finish time, I still don't really see it clearly. I still have a big area where it's red and where I have lots of people. So the next technique, and it's really cool, I have to warn you, is the hex bin polygon scatter plot. It's slightly more complicated, and I will explain to you the logic, show you quickly the calculations, and of course you can download the workbook when you come back to work on Monday. So basically here, just to show off, I've also added a parameter that allows us to change the size of the bins. So we can go from very big bins to very small bins. And it does allow us to answer the question, what's the most common half time and finish time? So here we see that anyone who finished between 1 hour, everyone who passed the half marathon around 1 hour and a half, 2 hours and a half, and finished between 4 and 5 hours is in the most common bin, with 17,000 of the runners being in that category. And so how to create this cool hex bin polygon scatter plot? What you need to do this is first to get the center of your hexagons, this is what we call the centroid. And the good news is that there is a native formula in Tableau that will get you the centroid of your bins. It's actually a couple of formulas. They're called hex bin X and hex bin Y. Just to show you, simply as simple as this at the bottom left of the screen. So hex bin X, then you enter the, then you enter the X value and the Y value, X bin Y, X value, Y value, and that gives you the centroids of your polygons. So you could use this and just use a shape mark, a mark of the shape of a polygon, but they wouldn't tessellate perfectly. I'm not going to show you, it's really not pretty. You just get those polygons that randomly appear on the screen. They make columns and lines, but they don't tessellate exactly.
Yeah, they might overlap or there might be gaps.
Yeah, they might be super far from each other.
You have to fiddle with the size and the layout and all that.
So the cool thing about the polygons is that they will tessellate perfectly. And to create them, you will need to have a formula that gives you the 6 vertices of your hexagon. And to create those 6 vertices, you need one formula that will give you the numbers 1, 2, 3, 4, 5, 6 for each hex bin. And then you will just need to offset from the center of your hexagons and rotate until you get the 6 points over. So these are the formulas. You will have time to explore. There's no need to open them and dig into them quickly. I've tried to make it as clear as possible on the slides. And the last thing you have is just a window average that will allow you to run around the centroid using a bit of trigonometry if you have some vague memories from high school or junior high. And that does the trick. So I'll just quickly build it with you and show you what are the... So you saw it's basically 5 different formulas. We've got the hex bin X, hex bin Y, then we've got our vertices ID, 1, 2, 3, 4, 5, 6. Then we've got an angle rotation, and then we've got the latitude and longitude, or the X and the Y of our vertices. So what I need to do is get my vertices up here. So my X will go on column, my Y will go on rows. I get this one and only one, but that's because I haven't given the level of detail, and the level of detail I want is actually to have every polygon, every different polygon. So I'll use hex bin finish time and hex bin half time. Again, when you have the slides, it will be much more easy to understand. And then I need to change to polygon type, because this is what it is all about, and bring my hex bin vertices ID bin onto path. It won't work at first. I really wanted to make this point because I've been knocking my head like it wouldn't work, and then after working on it for a long time, I realized what was the problem. So here we're using a technique that's called data densification. So we're creating bins. We just say the bins we created, they just have 1 and 6, and then we need data densification to fill in the gap between this 1 and 6. The problem is that data densification doesn't happen automatically, not all the time. So what you need to activate it here is to take your hex bin vertices ID bin, put it in rows for a moment, and then only will you get the option to show missing values. And when you do, and you bring it back to path, it's okay. It will work soon once I compute using my hex bin vertices ID. And now you will see magic. So let's say it wasn't working, because this is what I was facing for 48 hours until I figured out how it works. So I was here, I was having everything on the right column, rows, shelf, everything right, but it wouldn't make my hexagons. So I remind you, take your hex bin vertices ID bin, bring it here, and just do show missing value and send it back to the path, and then they will tessellate nicely and show all the 6 vertices. Then it's just a matter of formatting. You can of course use borders, and then you need a quick LOD formula to make sure you have all the runners inside one bin. So this is, I'll just open it quickly for you. I just say that I want to fix my hex bin half time, hex bin finish time, and that's when I sum the number of records so that I only have the runners that are within one hexagon. Et voilà. That was the hex bin scatter plot, everyone. Hope you liked it.
Well, yes. Tough act to follow. Just wanted to highlight one thing here, what we've done, or just reiterate why we're actually doing this. So the problem that we have when looking at a scatter plot like this is that these outliers here, they're very prominent, right? And there's a lot of stuff going on here, but visually we can't really see what's going on there. You know, just marking this gives me already 5,000 marks there. You know, I can just randomly select these and I get another 5,000 marks. But this is where the visual analysis that we love. That's why we're all here, right? We love seeing things visually and understanding things quickly by looking at it visually. That kind of breaks down because we have this problem of overplotting. So binning things into, showing a heat map helps. We see that there's this dense center here somewhere, or putting it into hexmaps helps, binning it helps, because we see more clearly what's going on here, what the distribution is. And really what these are, these charts that Jade has shown us, they are really two-dimensional equivalents of the histograms, right? We see where the peaks, kind of looking at it from top, like looking at a map, where the peaks and where the valleys, kind of where's the mountain range, where the most values. And so it's the analogy to the histogram in the one-dimensional case. Then you can ask, okay, in the one-dimensional case, we also added averages and medians and box plots, kind of getting summary statistics for that. What would be the equivalent of that in the two-dimensional space? Any ideas? Could be trend lines, right? So it'd be like, give me one quick, clear idea of what's the overall trend. How do you, is this a positive correlation? Is this a negative correlation? What are we looking at here? And so it is, of course, very easy using the analysis pane here to drag over a trend line. And if we choose a linear trend line, we do see there's a positive correlation. Obviously, the faster you are at halftime, the more likely you are to be also very fast at the end of the race. Now that's clear, it's somehow positive, but is it a linear trend? Or is it a curved trend like that? Yeah, it's tough. Again, the visual is not very clear. Here it has a visual, straight line somehow, but up here it looks more hump-shaped, right? So visually, we don't really know which trend line to use. It's a chicken and egg problem. We need to know the shape of the data in order to find the trend line, but we need the trend line to give us the shape of the data. So statisticians, of course, will know what to do. They'll look at the R-square or some other measure of fit. And you can do that by hovering over the line. We see it's got a very high R-square, so we can compare those. But again, you need to know which ones to bring to the race, which one to try out in the first place. I mean, this could be like a wobbly line like that. How do I, So another alternative is what we call non-parametric models. These are models that, these are trend lines that don't rely on a model, that they don't rely on an assumption of linearity or curvature or something like that. It just traces out the pattern in the data for you. And so this is one of the techniques that I learned when I was having problems with my data back in my business school days. It's one of the techniques I learned from the book that I mentioned earlier. There's one way you can do that in Tableau, and it's using moving averages. A moving average is fairly easy to create in Tableau. You basically have to duplicate, using the control key here, duplicate your vertical variable, or the variable on the vertical axis. You want to show a line, so we need to change that to line. You want to make sure that the table calculation is a moving average. Can you all see that? So there's a moving, I'll let you take a photo of that. Are you taking a video? All right, then I won't wait. I was doing a moving average, and we do need to go into the menu here, edit table calculation. And we need to do that across all runners. So I choose runner here. But we want to connect them according to the halftime. So we want that moving average to go from the left to the right. So our halftime is the one. So moving average, for those of you who don't know, it's basically you take a little window and you slide it horizontally through your scatter plot, and you calculate the average for each bin. and then you connect those dots, and you get a little line that traces out the pattern. So what we need to say is specific dimension sorted by halftime. So now it's using the horizontal axis to order for the order of things. And then because we've got 40,000 marks, we need to be wise about what kind of window size we want to choose. So by default, we get a window size of 2, which is very little for 40,000 marks. So we might want to try something like 1,000. And now we get a nice sort of smooth line. One thing to note though here, and this is a bit of a problem, in a case like this, so towards the edges, to the left and the right, it might get a little wonky sometimes. Also, we have a problem, it's very dense in the middle, but very sparse on the side. So that 1,000 is not ideal for all sections of the chart. So one thing you can do is here you can say, give me a null value when there are not enough records to do the calculation. And so with that, we get a nice little curve, and then we can use a dual axis chart to put the two of them together. We just need to synchronize the axes, and Tableau always gives me the measure names on color, but once I take that off again, I can choose my own color here. I can make it a little bigger. It's transparent. Maybe that's better. So you can see that nice smooth line there tracing out the pattern of the data, and it's fairly linear, but then towards the right hand side it kind of starts to bend down. So I did mention, and this, I won't go into the details here, but I did mention those problems, those edge cases, especially here where you only have a few dots. So there are actually better techniques which we call nonparametric models or scatter plot smoothers. So we've seen the moving average, which you can do with a table calculation, but there are better techniques actually. Some of them, anybody heard of any of those? So I've used the local regression quite a lot in my research, and I've actually recreated that in Tableau using the R integration, and it's just 3 lines of code really, and it will give you, again, a line that's fairly straight, and then it starts to bend down. But it's a little, and it depends on what parameters you choose. This is a very smooth one. You can have a little more rugged line as well, but it's a nice technique. If you have R and you know a bit of R and you use the R integration in Tableau, it's pretty cool. So you can find the pattern in your data, trace out that pattern, and then you can add trend lines again and see which ones fit that line, and then you get a parametric model again if you need that for your predictions or your forecast.
All right. I really like this moving average line because here, of course, we saw that our data is pretty linear, but if it was like sinusoidal or if it had a really weird shape that none of the existing native trend lines in Tableau could take, then you would be able to really trace the shape of your data with this. But I think most of you will agree if you are presenting to your top management, they might not want something as synthetic as this, they might want more detail. And so this is why we are bringing you the magnifier in your Visin tooltip. So this is a pretty neat trick, I think, especially if you have to present to your stakeholders and your management. And it's just using the Visin tooltip feature that was out in version 10.4. It's really good because let's say you're in a meeting with your top management and they're asking about the performance of that new sales guy whose name is Adam Smith. Then you would be able to just go find Adam Smith. And yes, this is because Florian is an economist that I was sure there would be an Adam Smith in there, and there was. And I find my Adam Smith, and then if I manage to hover over him, I can see exactly what is his performance compared to other colleagues that have been here for longer, like Mark Harvey or Caroline North.
it's like a little magnifying glass, and you
Yeah.
can zoom in there and see who's around, who's in that vicinity.
It allows you, if your management really wants to go into the detail, you still have the detail. You're not in a hex bin polygon map. And this is really easy to do too. What you need to do is just duplicate this sheet. So that's what I did. I just duplicated it. And then you remember earlier I was telling you that I created my bins myself. This was actually for this visualization because then I want to use them for some calculations. And what I did is I then brought the bin finish time and bin half time onto details. So you will see that I have it onto details on my main map, and I'll just use the one that I have already, and on the second one. And then I just need to bring this magnifier Visin tooltip sheet into my tooltip. So it's already here. I'll delete it, show you that it's not here anymore, and I'll bring it back so you can see what happens. So as easy as clicking Insert in your tooltip menu. Then you go for your sheet, which is called Magnifier. And let's see what happens if I leave it like this with the default settings. It's sad, I only get 1 point at a time because the default setting of my tooltip, and I'll zoom in on this because it's probably not easy to see. The default setting is to filter on all fields. So I'm filtering as well on the runner's name. So that's why I get one runner only in each magnifier. What I will need to do is what I've done just above for my title in the magnifier. I'll just filter on bin half time and bin finish time. So I just get my small square as a magnifier. And if I copy paste those values here, then we are back on track and we can see what's happening. And if you're wondering about the red lines that really give this magnifier effect, it's just boundaries that I've created with formulas. So I get the minimum of my hex bin, on like minimum of my x-axis hex bin, maximum, minimum of my y-axis hex bin, and maximum. And I use reference lines that I then color to make this nice frame. This is it. Yeah. How did you like this Visin tooltip thing?
Yeah, again, and it's a good point. I mean, it's exactly what I was saying. You know, that trend line it's summarizing the shape of it, but again, a lot of stakeholders, they want to see individual marks, and you know, with dense data, it's tough to make that trade-off. But this is another technique that you can use to see individual marks and avoid that overlapping, overplotting problem.
Yep. So if we go back to our summary slide, this is what we've covered today. So let's not go back to the easy techniques. You are now advanced level. So I'll just ask you quickly which of the more advanced things you're going to reuse. So quick show of hand, who would like to implement the magnifier in Visin tooltip? Yay! Heatmaps maybe?
Heatmaps, awesome.
Yeah, cool.
Yes.
Small multiples?
Boo.
Yeah, too easy, yeah. And what about the hex bin polygons? Yeah, so you're not frightened. All right, so the good news, the good news is you're going to get all the material on Monday, and you'll have the formulas. You also have our email addresses, I believe, if something's not working. And in the presentation that you will also get, you will have a link to some of the tutorials that we used to build this session.
Yeah, no, thank you, Jade. So we'll be around for a few more minutes. I've got a flight to catch, so if you have any questions after that, do feel free to reach out on Twitter or on email or however you want. Thank you so much for coming. We have a few more.
Yeah, we still have 6 minutes, so if someone has a question that would benefit the whole audience, we are happy to take it. Otherwise, we'll just do it individually.
Otherwise, yeah, we'll let you go to catch your flights, catch your trains. Oh, that's a question.
I mean, the real problem is, for example, you've got a very dense time series, and there could be
Thank you, guys.
billions of records, and what you actually want is a way of zooming in, magnifying a portion of that, and scanning across it quite quickly. I mean, clearly, if you don't want to show billions of records on a time series, you want to move the window somewhere and zoom in on that. How would you set about doing that?
Oh, that one we could use a filter with two sliders, and you can actually click on that and move it through the.
It's very slow.
It is it? Okay. Right, if you have a lot of, yeah, I don't know. Then it is slow. I don't know. Yeah. Do you have any other ideas?
No, yeah, the slider sounds like a good idea, and maybe with a highlighter. Like, do you know specifically who you're looking for, or what are you looking for exactly?
Well, I mean, you could have sensor information, for example, if you got a stream of measurements coming in, right, and you could go back way over, long over time and want to do various kinds of analysis on that. It's one thing just to show the waveform, but you want some kind of statistical analysis on it as well.
I think we'll need to brainstorm on this
Yeah,
and maybe create a new session.
Yeah,
Sorry, that's...
for the next version, we'll bring some time series in here as well. It's a good point. But if anybody else has any ideas for him, please speak out. Or any other questions you might have. Yeah.
Thank you.
One of the things that my team's done is we've put all US properties and US properties on the map. Of course, there's a load of dollars and means that whatever you use to magnify it, you don't get anything from it. Oh, thank you. I'll start again. I'm trying to work out a better way of dealing with US property data. So we have all US properties on a map in Tableau, and that's far too many dots to actually deal with in any meaningful way. And I think the hex bin polygons thing you've given us may be a way of handling that better. One of the challenges I had was essentially how we can zoom in more and get down to that deeper level. And maybe we have to use that magnifier thing that you suggested. But I was just wondering if you have come across any way, or anybody else come across a way in Tableau, when we zoom in on a map, changing that level of aggregation a bit more so we can extract more detail as we zoom in.
I mean, the good point is here also that the hex bins are very popular on maps, not just on scatter plots. So that's already good that you point that out. Jade seems to have an idea.
Yes. So the hex map scatter plot was actually an idea from one of our colleagues, Alan Eldridge. And what he does is that he has a dual axis and he gets the polygons and the marks, the original marks, like you can see here. Oh, you cannot see here. Oops. Let me get out of presentation mode. Oh. That's the one. Okay. And now if you see that? So he has both the hexagons and he has the original marks. So that would allow you to keep zooming in and maybe find the individual points that you're looking for. Yeah, you'll have all the links in the presentations. Yeah. Any other question? Nope. Thank you, everyone. You were great for last session. We're really happy that you were here with us today.
See you next year in Berlin, my hometown. Bye, guys.